Good afternoon, everybody, and welcome to this live and ticking event. For those of you who don't know me, my name is Nilesh Samani. I'm Medical Director of the British Heart Foundation, where I'm responsible for our research and medical activities. So I basically spend the money that the BHF raises while other people raise the funds. I'm also a professor of cardiology at the University of Leicester. So, as you know, these live and ticking events, which we're holding monthly, are really to bring to you the latest, our supporters, the latest BHF news and pioneering research in the comfort of your own home. And I hope very much that you enjoy this afternoon's meeting. This particular live and ticking event is special because it is one of a small series that we are doing to celebrate our 60th birthday. So yes, indeed, for those of you who didn't know, we are now 60 years old this year. The BHF was formed in 1961 when a group of cardiologists and philanthropists recognized the burden of cardiovascular disease, and under the patronage of the Duke of Edinburgh, who really remained as our patron for 60 years, set up the BHF. Cardiac events in 1960s and 1961, such as heart attacks, were stealing many lives. So before we kick off the event today, I just wanted to do a poll and see how much you know about how many people survived a heart attack in the 1960s. Can you just sort of take and let's see whether you think that, the number of people who survived a heart attack was 3 out of 10 people, 5 out of 10 people, or 8 out of 10 people in 1961 survived a heart attack. Let's see what you think. And the team going to put up the answers. Oh, you're all very familiar with the BHF and what we do, so that's a great answer. You're all right. That there's a stark statistic in 1961 that 7 out of 10 people died of a heart attack. This was, of course, due to limited understanding of the condition. Many patients received prescribed bed rest, often in hospital for a prolonged period of time, leaving their hearts untreated. And in response to this, the BHF was established to fund research that could lead to better prevention, diagnosis, and treatment, not only of heart attacks, but other circulatory diseases as well, that was stealing hundreds of thousands of lives. So today, thanks in part to BHF-funded research, at least 7 out of 10, and we did more than that, now survive a heart attack in the UK. So we've come a long way in the last 60 years. And BHF are immensely proud that we've funded some of the world's greatest cardiovascular breakthroughs during this period. From understanding the cause of heart attacks, to proving the life-saving benefits of statins, we have much to celebrate. So what I'd like to do today to start off this event is to just share a birthday video we prepared, which I would like to share with you now. Yeah.
There are times when we all turn to science for hope. These are the times to remember how far we've come. These are the times to remember the power of science. 60 years of mind-blowing, life-changing, barrier-breaking medical research. Wonderful, limitless, inspiring science, funded by fierce commitment, funded by energy, funded by love. 60 years of pouring everything we've got into creating moments like this. We've got this far together, and together we'll face our biggest challenges with even bigger ambition. More fundraising, more research, more time. Together, we're just getting started.
Great. Well, I hope it inspires you, and we're hardly done yet. There's so much more to be done. We look forward to what the BHF-funded research can achieve in the next 60 years. If you're really interested, by the way, if you're interested in some of the impact stories that were sort of trailed in that video, on our website, and we put up a link in the chat box now. It tells about at least 60. We selected 60 of our research impact stories to just provide in lay terms as to what has been achieved. They were really difficult to pick, I'll have to admit. You could have spoken about so many other things, but I hope you enjoy looking at them if you wish to the link that we're going to provide to you now. So now let's move on to today's program. Today, I'm delighted to be joined by my friend and colleague from Oxford, Professor Barbara Casadei, who is a BHF Professor of Cardiovascular Medicine at the University of Oxford. Professor Casadei has had, is an eminent clinical cardiologist. She's just recently been the president of the European Society of Cardiology and has huge strides in understanding and treating a common heart rhythm problem called atrial fibrillation. We're also honored to be joined by Mike Munson, who is a keen runner and a BHF fundraiser who will really share that thing that's so important for us, is the patient experience of atrial fibrillation. And we'll finish today's event with a question and answer session. So as the talks go along, please, we invite you to submit your questions in the Q&A function throughout the event, and we can cover as many of them as we can during that session. So before I pass on to Barbara, I have one other poll question that the team are going to share with you now. It is about atrial fibrillation, the topic for today. So team, can you just share the poll question? So let's just say how much, this will make Barbara's talk either redundant or very important by you telling us how much you already know about AF. If all of you say 5, Barbara, we will have to shorten your.
Yeah.
Okay. People answer the question now as to whether it's how much they know. Okay, a good audience. So in the middle. So Barbara, I think you have a very partly informed audience who I'm sure you'll take through to your great scientific work. So over to you, Barbara, now.
Thank you very, very much. As you've heard, I am a British Heart Foundation professor in Oxford, and before that, I was a British Heart Foundation Senior Research Fellow. So the first thing that I really would like to do is to thank you very, very much for having supported me and my research and many young people who trained in my laboratory over these years. I mean, without you, it wouldn't have been possible. So I am extremely grateful. So I am also grateful of what Nilesh and the video said, that we only just got started. And that is because we really need to work harder and work more if we want to understand atrial fibrillation better. So, first of all, what is atrial fibrillation? So normally, and this is, you may already know this, but let's start from the basics. We know that the heart, there is a natural pacemaker on the right upper chamber, and that then sends an impulse that to across the atria, and then to this little relay station, which is called the atrioventricular node. And from that it goes into the ventricle and causes the contraction and the pumping of the heart. And that is the resulting ECG. Nice and regular. This is the atrium. This is what happens in the ventricle. So first poll question, what does fibrillation actually mean? And I would say that, you have to find the best of the three, because to some extent, all three are relevant. All three answers are relevant, but there is one that is more relevant. So let's see. You know everything. That's perfect. That's it. You see, you have been underestimated, clearly, because that is exactly what it does. And if I can move on, okay, let me see. That's it. So this is exactly, not exactly, but more or less how it looks like. So you have a twitching of the upper chamber, non-coordinated activity, and from time to time, one of these impulses goes through the relay station and gets to the ventricle that then contract. So you could see here that there is a frenetic activity in the upper chamber by all of these little twitches here, and the rhythm is defined as irregularly irregular. So, you can feel the palpitations if the frequency is very high, But essentially, the atrial fibrillation, unlike the ventricular fibrillation, doesn't cause sudden death. But it is associated, nevertheless, with an increased risk, which is mostly really related to an increased risk of strokes that comes from the fragmentation of a thrombus that forms in this twitching atria. The heart failure is also associated, and both cause and consequence of atrial fibrillation, and also heart attacks. And we don't know quite how that works, whether it is an association or whether there is a cause effect. But nevertheless, this is a problem. And is a problem because atrial fibrillation is so common that 1 in 3 of us are expected to experience it once we get to old age. So, it is really a very big problem, particularly as the risk factors for atrial fibrillation are on the increase, particularly obesity. So, what is the situation, or what was the situation like when I started being interested in this disturbance of the heart rhythm? Well, as Nilesh said, we've had a fantastic run in cardiovascular disease, amazing. We've seen a steady reduction in premature death year after year. And only now we have this little twitch at the end that we really need to think about very carefully. But for years, we have been the most successful community in terms of science and impact on patients. So you have this, for vascular mortality. But then when you look at atrial fibrillation over the same period, there has been an age-adjusted increase in mortality, both in female and in men in developed country and also in developing country. So what is it that we are doing wrong, and why, after so many years of research at that point, we know that we can prevent a large proportion of the strokes by giving blood thinner drug, but we actually have never been able to demonstrate that putting patients back into normal rhythm would actually improve their survival or prognosis. So there's something missing in our understanding. So, when I started, I had a number of questions in my mind that I wanted to answer. So what are the mechanisms that underlie atrial fibrillation? And I put it in plural on purpose, because I think that we all lump it together, but actually there are different types of atrial fibrillations that may carry a different risk and may require a different management. And then we've seen that is associated with strokes. So what proportion of strokes are directly due to atrial fibrillation? And the alternative being that both atrial fibrillation and strokes are actually caused by an underlying disease of the heart, that causes both at the same time, possibly even independently. So that would be the alternative hypothesis. And so, because nobody likes to take blood thinning drugs, right, for all the limitation and things and the impact on one's lifestyle, can we actually select who really need these drugs better than we are doing at the moment? And we also know that what we know about atrial fibrillation and how many patients are out there with atrial fibrillation is an underestimate. We know that because we know that some patients have atrial fibrillation, but they don't know they have it. So it's called silent, undiagnosed atrial fibrillation. And we don't really know whether it carries the same risk as the garden variety of atrial fibrillation. And what is the link between this silent atrial fibrillation and, say, strokes and cognitive decline and eventually dementia? And so that's another question that is very close to my interest. So first of all, just to show, what we have discovered so far. So what we know is that atrial fibrillation is generated by a burst activity from the pulmonary vein that brings the oxygenated blood to the left atrium. and that once it starts, the burst is there and can be very frequent, but it needs to have a fertile terrain upon which then atrial fibrillation thrives. And atrial fibrillation itself is very good at making that terrain, also called substrate, even more fertile by causing some changes in the electrical and structural makeup of the upper chamber. And we have investigated this quite thoroughly and came up with new therapeutic targets and new mechanisms that have produced original work. However, over time, when one looks at that, then, I ask myself the question, yes, but that is what we do, say, in an animal model of atrial fibrillation. Take an animal model which is healthy, cause atrial fibrillation, and then see what happens. But actually, it might be that in humans, the atrial fibrillation is the result of a very long-term exposure to both genetic and environmental risk factors, lifestyles that, cause that kind of fertile terrain. And that is really important and should be our target, because if this keeps, if we don't influence this, then atrial fibrillation will recur. We can stop it for a while, but whilst we have this in place and we don't target what is upstream, it will come back, and it does come back. So how do we then tackle that question? And over the years, we have put together a circle that starts and finishes with humans. So what we normally, where we start is from tissue, atrial tissue, cardiac tissue, that we take, from cardiac surgery, bits of cardiac tissue that are sometimes cut in order to cannulate the atrium, some other times for other reasons. And from that tissue, we isolate cells. We do a number of studies really based on the human tissue. So in humans, you often have the ability to associate things, but sometimes you really need to know whether it's causal. So you ask your question, is this mechanism sufficient to create a substrate for atrial fibrillation? And that is the situation where we would have an animal model. In a mouse model, we can take away the gene that produces a protein or something, and then see, is that sufficient to increase the probability of developing atrial fibrillation? And we can investigate the mice very, very carefully. These are the atria of mice that we can map. And so, we can do a lot of that. And then if that again is promising, we might, in collaboration with our colleagues in the Netherlands, use a larger animal model to look at that. But essentially, the aim is to go back to humans. And we go back to humans by using advanced imaging and with clinical trials, and also looking at large prospective UK cohorts like the UK Biobank. And so through this, we really have the ability to make some inroads really on these important mechanisms and then test them back into humans. So, going to the question of what proportion of strokes is due to atrial fibrillation, this is the dogma. In atrial fibrillation, the twitching doesn't really empty the atrium effectively. So we form a thrombus. The thrombus goes into the bits, goes into the brain. They go into the brain and cause a large, usually very large stroke. And that is one of the three of the virtual triad, that are involved in thrombus formation, abnormalities of blood flow and stasis. And then we also have these other two that are very much driven by inflammation. And we are also studying this with my colleague and hopefully future BHF professor, Dr. Antoniadis, Professor Antoniadis, and we've been recently funded by the British Heart Foundation to look at the effect of inflammation as measured by routine CT scans into the risk of stroke in patients with or without atrial fibrillation. But, let's go back to this blood flow problem. And how do you think the blood flow would look like in the atrium? I mean, when I saw it the first time, because now we have developed this method to look at blood flow in the atrium. I didn't know we had our own washing machine type in the atrium. And you can see this really vertical flow that happens at every heartbeat and is really tight and really fast, washing the walls of the atrium. And you can see why normally one would not produce, would not have a thrombus in the atrium with this. And in fact, you don't always need blood thinning if you have atrial fibrillation, because you may still have some very good blood flow at the atrial level. But let's see what happens if you have risk factors for stroke and if you also have atrial fibrillation. And that is how the flow looks like. So you can see that this really tight vortex is much looser, that the velocities are slower, and you understand, how this might actually cause some problems. But what happens if we then take the same patients and we put an electric shock and return it into sinus rhythm, which is normally done in this situation, and we look at the patients again 4 weeks later, and you can see that you still, the vortex returns. But if you look, even with a naked eye, without actually having calculation, if you look at this compared with an unhealthy, normal subject with no risk factors, you can see that this is slower, somewhat not so tight, the vortex. And you may be tempted to think, it's because this is a patient who had atrial fibrillation and has a remodeled atrium. But actually, if you look at patients who never had atrial fibrillation, and we monitor them to make sure that they really didn't, it's very much the same. In fact, it's indistinguishable. So you can see here that you have two factors, the rhythm, but also the risk factors that affect the flow, and with that may increase the effect, at least the likelihood of having a thrombus formation and therefore a stroke. And in fact, we took this further and looked at patients with high risk of stroke, and we found that regardless of atrial fibrillation, the absence of this vortex and having a flow that is less organized is linked to very large infarct, brain infarct, strokes essentially, whereas a normal flow is not, or it shows in the brain only microvascular disease, not such a large defects. So, that we found is quite interesting and important, but is a cross-sectional association, right? So we say, this is it, this is what it is now, and is associated with this type of strokes and this type of risk factor. But we really like to look at it prospectively and be able to predict in the future, who is more likely to have stroke. And so we really want to improve the calculation of the stroke risk. And we want to know, as I said, how many patients out there have a silent atrial fibrillation, and do they have the same risk as the diagnosed atrial fibrillation. And with that, we went to UK Biobank, this great British gift to British scientists and international scientists. In fact, 500,000 people. I hope that some of you might be recruited, had been recruited in UK Biobank. And they were recruited between 2006 and 2010 And, you know, we know obviously a lot about these participants, and we know that in 100,000 of them, we will have data, not only genetic data, but also data related to imaging of the brain, of the heart, of the body, the carotid ultrasounds, cognitive assessment, you know, repeated over time. And in this cohort, we were extremely lucky to have had the British Heart Foundation funding an ECG monitoring study. And the UK Biobank did not have an ECG to start with, because it was thought that it would take too long to undress and put the electrodes, etc. And as it is a very big logistic operation, the ECG was not included. So it is particularly precious, this data that we are collecting, that will then be put back into the pool and be used by the communities for many years to come. And this is the device that we're using. It's like a sticky plaster that you put on your sternum here. And we have now monitored 10,000 of more than 30,000. We have money to do 30,000, but we would like to have more of this kind of age, where atrial fibrillation starts to become a problem, more prevalent at least. And we know that this is very well tolerated and it works, because the participants will keep the patch in a median of 12.6 days, and 98% of the ECG is good quality and analyzable. So what do the results, the preliminary results, because we've only recently started this show? So if we take the whole population of UK Biobank, we know how many of them have a diagnosis of atrial fibrillation, and we do not monitor those. We only monitor those who do not have a diagnosis of atrial fibrillation. So in males above the age of 60, approximately 5%. In females, about 2%. So how many do you think are living with undiagnosed atrial fibrillation? 1%, 5%, or 10%? Let's see what you think. 10%, whoa. Or you're very pessimistic. Right, no, the answer is, the answer has some twist, but you know, it's about 5%. But the higher the risk, for instance, in patients who already have a diagnosis of cardiovascular disease, but not necessarily, you know, of atrial fibrillation, other diseases, then it can be up to 10% or more, and also depends on the length of the recording. But, you know, in this relatively healthy population, like UK Biobank, it is 5%. So what will this study achieve then once we have done? Because, you know, what it actually happens here is that we are recording the atrial fibrillation, but we are recording all sorts of other ECG abnormalities that people are not aware of having, and the significance of which we actually don't know. And so, you know, one of the main, several main aim of this study is to evaluate the prevalence of all silent arrhythmias, their risk factors, and their natural history. I mean, what does it mean to have that? Does it carry an increased risk? Do we need to intervene or not? Or do we do more harm than benefit if we do intervene? And that, I think, it's a very important, you know, to know what to do is important, to know what not to do is equally important. We can then use genetics and other data within UK Biobank to understand what is really behind atrial fibrillation and stroke and the risk of stroke. We can see whether if we combine the imaging, the genetic and other data, we can improve the calculation of stroke risk, as I said at the beginning. And these are, if you like, relatively short-term aims of this study. But then we we also have long-term studies, long-term aims. One in between is to really understand what is the relationship between atrial fibrillation and imaging of the brain and cognitive function, but also prospectively to see what is the impact of silent atrial fibrillation on the future risk of stroke, heart attack, dementia, vascular death. We also want to know what is the impact of the burden of IF. At the moment, whether you have 30 seconds of atrial fibrillation or 24 hours of atrial fibrillation, you have a label of atrial fibrillation and you're treated the same. So, but we really want to know whether that matters, because 30 seconds of atrial fibrillation may not be as risky proposition as having it all the time. And so that, particularly for stroke and cognitive decline. And at the moment, because of the situation we are in, we are also doing recordings within a repeat imaging study for looking at the impact of COVID-19 on brain, heart, etc. And we would also look at the impact of COVID-19 on heart rhythm. So, with that, I have really finished my talk, and I just want to show you the people who have contributed to the data that you've seen today, and to give you the idea of the diversity of people that work in British labs, essentially. Some of them are collaborators, the one with the stars, the one in scrubs are doctors, the other are scientists, but it is a marvelous community, and may that last. Thank you very much for your attention.
Barbara, terrific. Thank you so much for a very excellent presentation. I'm sure it will generate a lot of discussion and so forth. And I'm glad you showed the last slide with the flag zone. I didn't want to mention the football last night, but I will now, and how much it lifted the country. So thank you for showing the flags in your last slide. I'm sure colleagues on the Zoom meeting are very pleased about what happened yesterday. At least most of them, I hope. Please. Okay, so look, before we come to question and answer, it's a real absolute delight to welcome Mike Munson to the meeting. And Mike's really, as I said, a long distance runner, a great BHF supporter and fundraiser. And Mike's going to really tell us why this is so important in terms of patients and his lived experience with AF. Over to you, Mike.
Good afternoon, everybody. I always considered myself very fit and healthy going through life. I very rarely went to the hospital unless I had a broken bone or something like that. I've always exercised. I've never been overweight. I eat good food. I've never smoked. I drink very moderately. There's no family history of heart problems. So I had no reason to suspect that I was going to have any heart issues. And then about when I was nearly 50, this was in 2000, I lined up for a 10K race, and it was in December. It was a local race, fairly flat course. And after just a few hundred yards, I felt completely drained. I had no energy. I didn't know what was happening, but I just had to stop. And I waited for, I don't know, a few seconds, tried to restart, and I kept on going, stopping, restarting, walking, jogging around a 10-kilometer course, and then collapsed at the finish, just exhausted. A friend took me home, and then I went to the hospital. I was tested, and I went through the sort of usual tests that people have when they might develop something like atrial fibrillation, but nothing was ever really done at that stage. And this went on for about 6 years, and I kept on trying to run, and I would get dizzy, and I would black out, or fortunately, if I felt dizzy and stopped, I wouldn't always black out, but this would happen time after time. Unbeknown to me, I was in persistent AF. In 2006, I moved home to live in Suffolk, and I introduced myself to my local GP and explained that I had this ongoing problem. He referred me to the local hospital where they tested me. They referred me to Papworth, which was great because this was the first time that I'd actually been to a regional cardiac unit. They said I was in atrial fibrillation. They explained what it was. They said there was a possibility that they could correct it using an ablation. I had an ablation in 2007, which unfortunately didn't work. So they then put me on medication, flecainide and low dosage aspirin. It didn't stop the dizziness and the blackouts. They actually got more frequent, and this went on for several years. And then in 2013, I went to my GP for my annual review of my medication, and he was quite happy just for me to continue on what I was on. But I said, I'd really like some sort of check, because I've been going along with this AF for 13 years now, and we had an attempt at an ablation that didn't work. So he referred me back to the local hospital. They put me on a 24-hour monitor, during which I managed to take part in the club 5K race. I did collapse, and which was quite normal for me at that stage. And I was quite pleased that I collapsed during it, because I didn't actually hurt myself, but I knew that the monitor would have recorded something. So the following day, I drove to West Suffolk Hospital, which is about 16 miles away, dropped off the monitor and tape. And when I got home, I had a phone call shortly afterwards from the cardiologist who said they wanted to see me. So I explained that our car was, my wife had gone off in our car, and I only had my bike, but I said, if they really want to see me now, I can cycle over, if you like. And she said, no, get your wife back and get her to drive you. And I said, but I'm fine driving. And they said, we don't want you driving. I said, but I've collapsed hundreds of times running, but I never black out driving the car. So I think she didn't see, I was being sarcastic, but she didn't see the funny side of that. Anyway, my wife took me to hospital. I stayed in for 3 days for tests. West Suffolk were liaising with Papworth, and eventually they put me on beta blockers rather than the flecainide. And that did cut out the dizziness and the blackouts, but it left me very fatigued. And when I next saw my GP, who happened to be a member of my running club as well, I mentioned to him about that, and he said, well, that's why I never wanted you on beta blockers anyway, because I knew you wouldn't be able to run. So I was actually quite pleased that by this stage that I wasn't blacking out, even though I had this fatigue, which was extremely frustrating when I would have to stop halfway up the stairs at home. So, but fortunately, when I wasn't doing anything strenuous, like walking upstairs or walking up a hill or trying to run, I didn't feel any serious problems. And so I started doing what we call trail events, which were, we navigate around off-road cross countries. So this allowed, because I was navigating, and I would stop, this would allow my heart rate to come down and me to continue jogging along. And I would get round marathons doing this, but I would be taking twice as long as normal. But I was enjoying myself and I was keeping fit. So I thought this was fine. And then 2016, I started, I did one of these off-road marathons, and it was a bit quick because it was fairly easy to navigate. So didn't have many stops en route. And at the end, I did actually collapse, but not black out. I just collapsed from what I thought was exhaustion, maybe due to lack of training. I was making excuses, but a medic came along and did, after testing a few things, he said, I think you ought to go to A&E and get checked out. But after a cup of tea, I actually felt better, and my wife drove me home, and the following day I felt fine. So I thought, oh, I'm okay. A few months later, a similar thing happened. This time I actually was vomiting as well. And again, I rested overnight, thought everything was okay, and continued. And then in June 2017, this is now, I then actually did collapse and actually lost consciousness. And then apparently a runner behind me stopped, phoned the race director to tell them that somebody had collapsed and maybe wouldn't be finishing the race. Apparently whilst she was talking on the phone, apparently I got up and started to run again. She found me again about a mile later. This time I was unconscious. I'd had a sudden cardiac arrest. Fortunately, she knew how to do CPR, and she did CPR for well over 20 minutes, apparently, until the ambulance managed to find its way to the field. I then obviously got taken to hospital, and obviously I survived because I'm here now, I was obviously in a coma for 3 days. I've got my own ICD now. Now I can't run at all. I walk and jog a little. I try to exercise, and now my confusion is what I'm feeling now, which I feel fine at the moment. Sitting here, I'm fine. But if I try to exercise, that's when I get my problems. And I don't know whether it's my atrial fibrillation, because I am still in permanent AF. I have got, last year I developed a chest infection, and my GP did an ECG and sent me off to A&E because he didn't like the ECG. But it turned out the cardiologist said, this is your new norm. After having had a bypass, this is atrial fibrillation in your new you. So I don't really know. And since coming out of hospital, I've been trying to sort of think about how lucky I am and how I can help. So I first of all thought about the defibrillator, and then I realized that the local playing fields where I am didn't have a defibrillator. So I spoke to the local sports clubs there, and we raised money and put a defibrillator on the rugby club wall outside. So that's helped. And then I did some work with British Heart Foundation and BBC Radio Suffolk. They were doing CPR training all around Suffolk, and I went along as, here is somebody who this simple procedure CPR works on. And so I just spoke for a minute and it did that. And then this year, because it's the 60th year of the British Heart Foundation, we did a Suffolk 60, so that people were asked in April to do anything related to 60 to raise money for British Heart Foundation. So I tried to run every day for the month. I ran every day. Walked and jogged every day. I did about 3 miles every day for the month. And between 8 of us, we raised £6,000 for the British Heart Foundation. Just one other thing about AF was I also organised a series of trail runs to raise money for my local cardiac unit at West Suffolk Hospital. And one of them, because I was raising money for them, the nurses came out and tested for AF. And all the runners, there were 120 runners turned up. So they tested for AF. And afterwards I said, how many people did you find with AF? They said 1. And of course, and I said, well, who was that? And they said, well, you know you've. So that's me. And I'm feel happy and grateful that I'm still alive. I'm very grateful to people who saved me that day back in June. And I'm still fitter and more active than a lot of people. And so I'm very grateful to everybody, including the British Heart Foundation, because I've still got their, during lockdown, I used their DVD on exercises.
Great. Mike, thank you so much, really.
Thank you.
Thank you for sharing your experience with us. I mean, what it illustrates to some extent, and we'll come to questions in a minute, is a sort of very different range of people and their experiences they have. You know, somebody in the chat was talking about silent atrial fibrillation, and Barbara alluded to that as well. So, you know, different people get affected in very different ways, you know, with AF, but you can see the toll it can take on some people, and yet others, you know, it's picked up at times when they incidentally present with something else. So it's really a remarkable, diverse disease. As you said, 1 in 10 people, you know, Barbara was talking about 10% of people at the age of 60 to 65 having it, and 1/3 developing it at some stage during their age. So what we need to do as a BHF, you know, to our research funding, is to go to the upper level that Barbara was talking about, not only treat the disease, but try and prevent it in the first place. I mean, the ambition, if I had for the next 60 years, is that in 60 years' time, AF should be something historical for us. You know, we should be able to cure it rather than, or prevent it, rather than it coming up and affecting lives. Leanne, let me turn over to you. So thank you both, Barbara and Mike, for your presentations. We really literally got, you know, about 10 or 12 minutes for questions. There's so many that I'm really a bit worried that we won't be able to cover everything. But Leanne, have a go.
Thank you, Nilesh, and thank you again to all of our speakers. We've had some lovely comments already about the talks we've had. So my first question is for you, Professor Casadei, and it's a question someone in the audience submitted before the event, and this person asked, what causes atrial fibrillation in younger, otherwise healthy people?
Yes, I think that when that happens, and it's quite rare, one needs to do a proper workup, you know, and make sure that exclude that there is a problem, an endocrine problem like thyroids. That problems are quite commonly associated with atrial fibrillation, and that there is an inherited disease, you know, like hypertrophic cardiomyopathy or some other conditions that predispose to atrial fibrillation, and maybe they come out of the blue, and other such thing. And then, you know, there is also, you know, sometimes a more subtle genetic predisposition for atrial fibrillation, you know, to have relatives that had atrial fibrillation at young age makes it more likely to experience atrial fibrillation at a young age. And always, not how, you know, one can be 50 years young, you know, always think of ischemic heart disease as the underlying cause, because ischemic heart disease is common and can sometimes manifest itself with arrhythmias, amongst which there is also atrial fibrillation.
Yeah. Barbara, being Italian, you didn't mention the most obvious cause. If I saw a 31-year-old male person with AF, I would say, how much alcohol are you taking? Absolutely.
Yeah, I mean, alcohol, binging in particular, but even alcohol consumption very commonly associated with atrial fibrillation, and massive reduction in the recurrence of atrial fibrillation with alcohol abstinence. I mean, I didn't want to give you the bad news, but this is actually what happens. The Australians have published a paper on that. They managed to get a certain number of patients to abstain, patients who were drinking quite a lot. And the reduction in atrial fibrillation is almost equal to an ablation. So it is a massive effect, absolutely, Nilesh.
Thank you very much, Professor. Thank you. That was very insightful. And we have a few other questions for you. We've had a lot of questions coming in. And this question is from someone who was a nurse, but has been retired for 12 years now. And they've asked, when I was a nurse, I remember that in the early years of my career, we used digoxin frequently, but this seems never to be used now. So I wonder what the reason is.
No, we still use digoxin, but digoxin is more effective in keeping the ventricular rate, you know, the pulse rate down at rest. So because it works on that relay station, the atrioventricular node, and decreases that, the ability of impulses to go through, but it can be overridden. So during exercise, the effect of digoxin is much smaller. And because we have beta blockers that are more effective, both under resting condition and particularly when it's needed, and that is during exercise, we've just heard what can happen, then you know, there is a preference towards beta blockers. But digoxin is still used as an alternative, particularly in patients who have a lower ejection fraction. That is a diagnosis of left ventricular dysfunction or heart failure.
Thank you. That's good to know. Another question we've had come in is why can atrial fibrillation keep recurring?
Yeah, that is because we're not looking at what is upstream, as what Nilesh was saying, and is that substrate or fertile terrain. We have looked downstream. It was convenient because we could do something about it, but I think we have now achieved what we can achieve by looking downstream of atrial fibrillation, and we need to look upstream. Otherwise, it will keep recurring. Yeah, that is.
Thank you. And one last question for you. How much of an improvement does a pacemaker give to atrial fibrillation sufferers?
That is, it's a very interesting question, because you need a particular type of pacemaker. Essentially, in patients who do not respond to either rhythm control or rate control, then there is the option of burning that relay station, that atrioventricular node. And so dissociate completely the upper chamber from the lower chamber. And the pacemaker would then pace the lower chamber at a steady rate. And you forget what's going on upstream, right? So that is not something that is a first line of treatment, but is something that is particularly done if there is a risk that this very high rate could compromise the lower chamber. There is a trial that will be presented at the European Society of Cardiology in August, at the end of August, where this has been formally compared. And so, you know, it is an alternative, something that one can do. And there is also a different way of pacing now that also looks potentially promising for patients who do not respond to beta blockers or to rhythm strategies.
Thank you very much. And thank you for joining us today and for answering our questions. And we have a few questions for you, Nilesh, before I leave it to you to close the event. So we've had a question that says, due to a personal connection to the BHF, I know the BHF is the leading cardiovascular research funder in the UK, but before my connection, I never used to know that. Do you think there's a misconception around the BHF's work, and how can I help to change the public's perception?
Yeah, I mean, that's a terrific question, whoever asked that. I mean, because we don't have research in our title, you know, as a charity, many, you know, if you ask the person who's high street, what does the BHF do? We of course provide support for patients and information for patients and so on. But we don't, you know, but many people don't know about research. So I think we're going to, you know, we're going to, as a BHF, are going to think about how we change that perception of what the BHF is. We are primarily a research funder, and we make advances through research. So I think you'll see a change coming up in terms of making sure the public are aware of what we do. You know, I mean, science is now really the top of everybody's agenda, given what's happened with the pandemic. And the BHF want to demonstrate to people that we are really ultimately a science funding organization. So you will see some of the messaging that we provide changing. But except it's a difficult task, because unlike CRUK, which has got research written in their title, the BHF hasn't. And we don't think we can change our name now. I mean, it was invented 60 years ago, but you know, it is a challenge for us, and I accept that.
Thank you. And then one final question for you. Someone said, happy 60th birthday to the BHF. And the question is probably going to take longer than what we have time left. But if you had to, in brief, what are the BHF's hope for research in the next 60 years?
There are so many different ambitions, to be honest. Where would I start with that answer the question? I mean, just the topic we're discussing today. If through BHF supported research, we can prevent people, you know, by understanding the mechanisms of how atrial fibrillation happens, not the downstream consequences, you know, in putting people on blood thinners and so on with their own complications. If you really truly understand the different types of atrial fibrillation and why the mechanisms behind by which they develop, then there's a hope, of course, that we'll develop ways of preventing it, new drugs or other therapies that might prevent it coming on. Wouldn't that be a great advance? You know, 10%, you know, 1 in 3 people will suffer AF in their lifetime. Would it not be great? So that's one area. That would be an ambition that the BHF would have. Another one, and I'm very quite hopeful we'll do, is around heart failure and the ability to protect the heart and reverse the consequences of the damage that heart attacks and other things do to the heart. So we fund a lot of cardiac regenerative medicine research, as you know, and an ambition would be to really do that in the future, you know, to make that reversible in the future, which isn't now. And finally, you know, and the third, you know, I can give you another dozen examples, but finally, the other one I want to comment on is that we don't only fund heart research, but we fund circulatory research as well. And vascular dementia is ultimately, you know, about a third of dementia is due to vascular problems, circulatory problems. And we hope that we can make inroads into understanding and preventing vascular dementia happening. So there, you know, those are just 3 examples of where we think the BHF can play a really important role, but there's a lot of work to be done in other areas as well.
Thanks, Nilesh. That's all the time we have today for questions. We will do our best to answer all the other questions we've received offline, but yeah, I'll leave it up to you to close the event.
Look, I've seen some of the questions online. I'm terribly sorry that we can't deal with all of them. Leanne, if I may have the opportunity, I just want to pick one up that I saw earlier, where somebody says, does everybody need to be on a blood thinner if they've got AF? No, they don't, you know, and there's a lot of information about this on the BHF website. So please avail yourself, as was said earlier, around the information you have on our website. We also have a very fantastic helpline, so we can you please speak if you feel there's a specific question that you think they have a helpline to be able to address. Please to direct you there as well. I'm really truly sorry that we don't have time to deal with all the questions, but I hope that this is at least given you some background to the sort of research that BHF are funding. What I wanted to do, of course, is to end by thanking Barbara and Mike for their wonderful presentations today. Hope you enjoyed it. I hope you are enjoying the live and ticking events, which are really there for you. You know, it's great to be able to do this in your own home and to be able to just enjoy some great speakers, you know, that like the ones we've got today. We've got some really great lineup coming up. So the next one, which is in a month's time, is going to be given by Professor Gianni Angelini, who is Professor of Cardiac Surgery at Bristol. Gianni's led some of the major developments in terms of bypass surgery, and I'm sure he'll be talking about his work in the area, but there are a number of others coming up as well. So please feel free to join us. And as I mentioned right at the beginning of the discussion today, you know, we got our 60 impact stories on our website, and I hope that you're able to access those. So I think I've covered most of the things I wanted to say. To thank all of you for attending today, and I hope you have a wonderful evening again. Okay, thank you, everybody. And oh, by the way, sorry, one last thing. There is a survey that we'll ask you to complete to shape our future events. So please do this. And for those of you who want to see the slides again that Barbara presented, a recording of this will be available on our website from next week. Okay. So good evening, everybody, and thank you for joining us.
Thank you. Thank you very much.